Well, thank you very much, everybody, for inviting me. I'm Brandon Peecook. I am the curator of the Idaho Museum of Natural History, the paleontology, really vertebrate paleontology curator. And so we're in Pocatello on the campus of Idaho State University. And so before I was here in Pocatello, I was a postdoc for a while at the Field Museum in Chicago. And before that, I was getting my PhD in Seattle at the University of Washington. So I know you've had Liz Nesbitt recently. She was one of my committee members and Kelsey Abrams, who's a preparator at the Burke Museum. Kelsey's prepped a lot of the really great stuff that I did as part of my dissertation that's mostly like Africa focused. Um, but I'm really delighted to come talk to you guys today, especially an Oregon crowd. So I'm in Idaho now, like I said, and come from uh, being at the Burke in Seattle and Washington for a long time. And so when Tara first emailed me, he actually reached out to me about a paper I was on recently that is about the Ice Age megafauna from Idaho. So in the immediate area of the town I'm in, Pocatello, is this American Falls Formation, which is a really, really, really rich Ice Age fauna from the last interglacial. So I always like to talk about it as if this is when Idaho looks like it does today. It's not cold, scary Ice Age. It's kind of just looks like now. It's an interglacial period, but there's just elephants and saber-toothed cats next to the caribou and things like that. And Tara emailed me because we have a humongous amount of genetic material inside the bones from American Falls. These are bones that are just like in what is basically the Snake River. They were deposited in sands. You find them loose. And for whatever reason, no matter what animal that gets checked, we have huge amounts of mitochondrial and nuclear genetic material. And so several of like the very well-funded sort of de-extinction people have come by Pocatello because they want to get a direwolf or they want to get a mammoth or they want to get a mastodon genome, which is really cool. And so it's funny because so Tara emailed me about that, I think, was her initial email. And then I said, well, what do you guys want to talk about? I could talk about that. And then eventually she kind of asked me, what do you want to talk about? And I said, well, what about dinosaur stuff? Because there's really not that many dinosaurs in the Pacific Northwest. You guys are in Oregon. I was in Washington for a long time. Now I'm in Idaho. We have this little quadrant of the country. Um, Certainly, America is a dinosaur country. There's a lot of dinosaurs from North America and from the United States in particular. But I think it'd be kind of fun to walk through these, and especially if you guys are the people, I would guess, who might know about other loose bits floating out there. So I like using this image because this is an image of some dinosaurs from China, but these are animals that are very much like Middle Cretaceous dinosaurs that you would find in North America, at least Western North America, about 100 million years ago. And so these are dinosaurs also that aren't, Stegosaurus and Brontosaurus. They're exciting and new seeming because these are dinosaurs that have only really recently become known to science. So how I like to start talks like this, you guys do not need this background, but just in case you really want to refresh yourself, there's the geological time scale. And so as a curator, and when we make exhibits in Pocatello, we want to help contextualize the things that people are finding. You guys just showed a bunch of great stuff from all kinds of different environments and all kinds of ages and all kinds of different taxa during your show and tell just now. And so I always like to think about it as like when we know a lot about the past, it's because we've synthesized almost a global fossil record. If you have fossils from all over the world, you're going to get pretty good coverage of most periods of time, and you can draw pretty big picture stories. And so, for instance, in Idaho, some of you might have done some rock hounding around here. We've got really excellent Cambrian rocks. There's tons of trilobites, tons of good stuff from Idaho. Great Devonian, lots of reefs and things like that. And of course, a couple of interesting, like I'm a vertebrate paleontologist, so backboned animals, right? Armored fishes and things like that in the Devonian. We have some from Idaho. Our early Permian rocks are Phosphoria formations, super famous for making fertilizers. And I would say even more important, even though not economically, for Helicoprion, the buzzsaw shark. And so that's the shark with the circle of teeth in its mouth. The museum here in Pocatello, we're a decent size museum, although we're sort of small. But we have the most Helicoprion of any institution in the world by, 5 or 6 times. We have like 120 specimens or something, and there's only about 200 that are known that are really nice in museum collections anyway. So the Permian in Idaho is super important for that buzzsaw shark. If you don't know what I'm talking about, Google it. We got some good Triassic rocks. We've got a little bit of Cretaceous, which is what I'm really going to zoom into today. And then Idaho's really famous fossil-wise, you guys probably know, for the Hagerman horse. So about 3.5 million years ago in what is now like the Boise suburbs, there was a big lake And that lake preserves things like Equus simplicidens, which is the first horse down on one hoof in the modern genus Equus. And so that's a national park unit. It's a national monument. And then we have those Ice Age fossils that are very, very, very young, talking about 100,000 years old. So probably pre-human contact with North America, but um, also containing fossils of tons of living things. The same rocks that we get mammoths and smilodon out of, we find fossils of black bears and foxes and turkeys. And so it's a very fun in-between kind of place. And so I want to focus in on the dinosaurs, though. So when I started at this institution in Pocatello, I started making exhibits to show people all these amazing Idaho fossils. And if you guys look at that timeline, you're going to quickly see what one of my problems is. Every single person who comes into the museum actually says, do you have any dinosaurs? Where are the dinosaurs? How about dinosaurs? Do you have any dinosaurs? Because that's what they want. And so you have to remind people, well, there's place and there's time. Idaho is absolutely incredible for the Pliocene and the early Permian oceans. Idaho's bad news if you care about the Jurassic. You have to go somewhere else if you want to learn about the Jurassic. And so what it forced us to do, and what I'm going to tell you guys a little bit about today, is this exhibit that we just put up last year that really, really, really does a deep dive into the scrappy, kind of garbage record of Idaho's Cretaceous that us experts can actually see the fauna and the flora, and then tried our best to give it a sense to people. And so I wanted to really zoom back out from the Idaho thing because you guys are so close, right? You're my neighbor. This is a map from the paleobiology database, and the only search terms I put in are Mesozoic and Dinosauria. And so this is literally, should be, a pretty comprehensive published records of dinosaurs from the Mesozoic. So it's not birds, but there are bird fossils in here. Distribution. And so if I was there with you guys in person, I would treat you like one of my classes and definitely make you talk to each other and make some observations. But I'm sure you've all kind of done this before. Dinosaurs are really well known from from the United States, but that's really in a really, really, really tight band in mostly the Western states. So if you want great dinosaurs, you go to Montana or Wyoming or Utah or Colorado, increasingly maybe Mexico or Texas. You do not go to Illinois. You don't really go to California, even though it seems like you should because there's so many rocks. It's always on the interior. And so here we are all sitting up in the Pacific Northwest, and Washington, Oregon, and Idaho are kind of depauperate when it comes to the things the public really wants. Of course, we could rent a T-Rex or buy a Stegosaurus or something, but it's more fun to focus on what we have and kind of work from there. And so this, of course, is one time slice of what North America used to look like. I'm so pleased that we just saw some Niobrara fossils from Kansas. How do you get sea monsters and, giant seashells from Kansas? Well, as you guys all know, North America used to be covered by a seaway that went all the way from the Gulf of Mexico up to the Arctic Ocean and also up through Hudson Bay when water was at its highest, when sea level was at its absolute highest. And so if you think about this, and like I said, I'm sure this is a crowd that kind of already knows this, the best places to find fossils are places where animals were living their lives, plants were living their lives, dying and getting buried and getting preserved. And so honestly, most of the great dinosaur record that this continent has is from the western margin, well, you could call it the eastern margin of the western continent, on the shores of that seaway. So really, really, really important and famous insights that all of us humans have into, say, the latest Cretaceous, right before the asteroid hit. T-Rex, Triceratops, Quetzalcoatlus, they all come from places like Montana in rocks that are 67 million years old, 66 million years old. Down in Utah, there's some interesting rocks that are older. As you guys probably know, there's always new finds coming out all the time. Places like Utah and New Mexico, like I said, are kind of exploding right now. There's lots of really exciting stuff, Mexico included. But again, what we're seeing, what we actually have from North America for dinosaurs is really, especially in the Jurassic and the Cretaceous, this sort of strip that was just happened to be a really nice environment to preserve these animals. Now, you can't tell me that if I'm in what will someday be Montana and there's 40-foot animals walking around, that those same animals aren't also in what's going to be Oregon and Washington and Nevada and California. But those places don't have rocks where we can find those animals. And it's a real struggle to try to show people what we do have. And so I thought I'd start with you guys. I don't know if this is on your radar or not. I don't know if people can give thumbs up or something like that. Have you seen this before? This is your dinosaur. Do you know about this? People can use emojis, I guess. So this paper came out in 2018. Greg Rotalik was the lead author on it, but there's kind of several people on it. It's not the foot over on the right. It's none of the three things on the right. It's the six images on the left, which is just six views of one pedal phalanx, one toe bone of some hadrosaur dinosaur. And so some of you maybe have rock hounded in the Hudspeth. It's a marine shale unit. It's early Cretaceous. It's in the Albion. I think it's kind of a fun thing because it's definitely just a dinosaur that died and washed out into the ocean, probably a bloat and float situation. And all of Oregon, for as big as Oregon is and how beautiful Oregon's geology is, the only non-avian dinosaur that is published, so I'm curious if you guys know about anything else, is this one single toe bone. There's rumor of a pelvis from the Cape Sebastian sandstones you guys might know about. I've heard from people who kind of have seen it that it actually might be part of a sea turtle and isn't a hadrosaur sacrum. Either way, not much going on in Oregon. And that's a rock record problem, right? In real life, in your time machine, if you got out of your time machine, you'd see dinosaurs in what will be Oregon, but the rock record doesn't really preserve them. When I made this talk, I actually learned for the first time, I did not know this, that there's an ichthyosaur centrum from almost the exact same spot as this hadrosaur thing, phalanx. That's kind of fun to imagine. The ichthyosaur swimming by the dead hadrosaur. It's kind of cool. That's all you guys got. It's not very much. Let me tell you about Idaho, because for a long time, we weren't very much better. And so here's some rocks that are a little bit younger in the Cretaceous. Your ornithopod, your hadrosaur form thing, is I think like 110 or something like that. Yeah. So we're in the early part of the Cretaceous. So forget the Triassic, forget the Jurassic. None of us have any of that. So forget it. But Cretaceous, you guys have a toe bone. And Idaho has this one packet of rocks called the Wayan Formation. And what is really interesting and has been really interesting about this formation for a long time is that it preserves an upland setting. Almost everything that we know about, including things like the Morrison in the Jurassic, and all the rocks in Utah and Colorado and Montana, for the most part, are kind of lowlands, like floodplains, coastal areas. That's what I had on that slide a couple back with the first map. Whereas this Idaho unit is preserving high energy systems. So you can think about it as like rivers in sort of like, not like steep mountain valleys, but like pretty hilly areas that are moving really fast, high energy river systems. And so what that means is that a lot of the fossils are coming out in big conglomerates and there's very little association. There's almost no articulation, very rare. So it's just chunks and bits and chunks and bits. And there's this one guy, LJ Krummenacher. Some of you may have heard of him, or maybe you know LJ. He's an Idaho guy and he's been like rock hounding and finding stuff his whole life here in Idaho. And he's like the reason a lot of our dinosaurs are known. So this is interesting though, because the Idaho dinosaurs are very close geographically to those lowlands that are preserving fossils really well, but it's preserving potentially a very different ecosystem. You guys might know that the fossil record is sort of like notorious for not sampling what we would call the highlands, deserts and mountains and things like that, where it's not a lot of water moving, not a lot of sediment moving, very hard to be preserved. So it's pretty exciting. And so the most famous dinosaur from Idaho, if you guys know anything about Idaho's dinosaurs at all, most people don't, so don't feel bad, is this little ornithischian dinosaur. It's called Oryctodromeus cubicularis. It's actually also known from some rocks in Montana. It's a little sort of burrowing animal. If you know Thescelosaurus from the end Cretaceous, it's related to Thescelosaurus. And it's pretty cool. We do find this animal associated and even articulated sometimes because it digs its own graves. It lives in burrows. It has osteology. It has anatomy that shows us it burrows, and we literally find it in burrows. And also, it's been found with juveniles. Oftentimes, in the same little tube of mud, you'll get what you would think of as adult bones or large bones, somatically mature individual bones, and then several teeny little bits that are anatomically very similar and are interpreted always as juveniles. And so this animal became Idaho's state dinosaur last year as part of our efforts with the exhibit we made. And we convinced all those Idaho legislators that it was a good, made a home and raised a family. It was a good family dinosaur. And so now we have a state dinosaur, which worked pretty good. But the other thing you find if you go out to this Wayan formation, if you don't find a little piece of Oryctodromeus weathering out of the hillside, you're going to find a lot of egg shell. And I mean a lot. The first time I went out in those rocks to just look around and get my bearings, I stepped on eggshell like out of the car, like out of the car door, my foot was on eggshell. It's everywhere, everywhere, everywhere. And that's interesting. And so here's a place that the Forest Service in the Caribou-Targhee National Forest in Idaho had to put up a wooden barricade because dudes were just like riding their sweet dirt bikes and ATVs over this hill to like do jumps and stuff unsupervised. But right there where that paleontologist is bending over, there's actually a lot of eggshell and some of it is associated. And so in 2007, some of you maybe have heard of this, there was a couple of eggs that were mostly together. So they're very shattered, but like the actual shape of the egg is still present. And so that specimen was excavated very well in 2007 and then prepped. And it was rumored about in the paleo community for a long time. When I applied to the job to be curator of the museum here in Pocatello, the only dinosaur I had heard of was like, oh yeah, don't you guys have that set? And it is a set, it's a pair of really like huge eggs. And they're about 15-inch eggs from Idaho. And so that's not a body fossil, right? This would count as a trace fossil, but it's still a really compelling evidence of a pretty cool organism. So on the left there is a black and white photo from the publication that described these. So it's a shattered bits, and then there's an interpretive drawing. I hope you can kind of see it. When it's in person, it's very compelling, and especially the ends because the ends curve. But you can see not pretty, right? No one's very excited about this as a pretty museum specimen. But there's a lot we can learn from it. And it has a name, an UU taxon, an egg taxon, macro elongato uulithus, Carlisle. So it's a big, long egg. There you go. That's the name. And I agree with that. It's like I said, it's about 15 inches. And so at first, when these eggs were found, they were kind of talked about for a long time, and then they got assigned an UU taxon, but it's still sort of like, well, whose eggs are these? Because all we have really is the eggs. There's not little bones, as much as we might like, inside these eggs. And so I'll kind of cut to the chase, since you guys only wanted me to talk for like half an hour, instead of doing the whole murder mystery part of it. These are the eggs of a theropod dinosaur, so the lineage of meat-eating dinosaurs, but a relative of animals like Oviraptor, which is, of course, is really famous from places like Mongolia. And so Oviraptor was found in the 20s by Roy Chapman Andrews. I have to start saying 1920s, I guess, because we're in the 2020s. It was found 100 years ago or so in the Gobi. And so Oviraptor literally means egg thief, right? So when they went, they were finding fossils of, for the first time, of this little horned dinosaur called Protoceratops, and also a lot of eggs that belonged to that little horned dinosaur. And Oviraptor at the time was assumed to be the like egg stealing, egg eating carnivore. And in fact, in the 90s, a lot of groups from the American Museum of Natural History and people in Mongolia kept doing field work, and they found some of these type of specimens, which are Oviraptor skeletons, actually brooding on some of these eggs. So maybe this animal does eat eggs, I guess, I don't know. But it's certainly also, when it's associated with eggs, is very oftentimes caring for them. It's acting as a parent. And so oviraptors in general are these like extremely exciting dinosaurs. You guys all know that in the 90s, not only are there new fossils of things like oviraptors that are telling us about the reproductive attributes of these animals, this is the time when people are actually finding from places like China fossils that show us the feathers of these dinosaurs. And so animals like Oviraptor are very cool. They are not Stegosaurus and Triceratops and T-Rex, classic dinosaurs we've known about for 100 years. They're compelling, they're showing us the connection with birds, and they're making us think about these animals in a very different way. And so we actually know a whole lot now, like kind of a lot, mostly from Asia, about how these animals lived, how many species there were, how they reproduced. If we end up talking about it, we can talk all about some of their cool reproductive stuff. But what you're seeing from that 2009 paper down there at the bottom, tons now of known actual nest sites of these animals. And you can see these huge circles of eggs, and the eggs are always laid in pairs. The female lays 2 eggs at a time. They come out together as a set, and they're kind of arranged like that. One thing that's really cool is there's some decent evidence that the males maybe care for the nest because the signatures in the structure of the eggshell indicate that like there are probably multiple sets of females laying their eggs together in the nest, which is exactly what animals like ostriches do today. Anyway, really fun, really exciting, really interesting. There's also been recent work on like the biomolecules that are in some of these shells, and there's really good evidence that at least some of the time they were blue for oviraptors. So that like drawing there on the left isn't supposed to be too fanciful. That's based on real geochemistry that people have done these days. And so that's really exciting for Asia. I'm going to let you take this in for just a quick second. This is the group of oviraptors that are known from North America, the clade from North America. Some of these are pretty lightly known, if we want to be generous. The one up at the top right there is a pubis. The really nice one on the bottom and kind of the middle, Hagrippus from Utah. It's gorgeous, but it is, yes, just a hand. So compared to Asia, where some of these animals are known from many articulated, unreal, gorgeous skeletons, From North America, oviraptors are really poorly known. Only one, that one on the bottom right there, called Anzu, actually has most of its skeleton. If you guys go to a lot of museums these days, you might see a cast of Anzu. It's at the Carnegie, it's at the museum in Salt Lake City. It's kind of everywhere. It's the only one that's really well known, and that's from the same rocks that T-Rex and Triceratops come from in Montana. And so, in general, this is a really compelling and interesting group of organisms. And so, if we come back to Idaho, what's really cool is uh, some of these eggshells that are known from Idaho were also known from China. And I mean that meaning like the actual structure of the eggs, how they were laid, their dimensions, and then even things like the microstructure. So the very small ornamentation on the outside of the egg. And then if you cut the shell and do it in like a histological section, there's signatures that let you tell apart like a gecko egg from a chicken egg from an alligator egg. And these are identical essentially to the Idaho eggs. And so that's very cool. And the thing that really made it work and get exciting was that one of these clutches of eggs from China was found with a baby inside of it. And so this is a very famous fossil at this point, but again, it's like relatively new, nicknamed Baby Louie. I guess it's 8 years old now since it came out. And the actual genus of this little oviraptor, and now we can be confident that these eggs belong to an oviraptor, is called Bebe Long, which I don't know if any of you speak Mandarin, but Bebe Long translates to baby dragon, which is a pretty cool name. And so this let us understand that if we find this loose eggshell, and people now have found it in places like Utah, even Wyoming, are these kind of giant oviraptors are in North America too, our record is just much scrappier. And so it becomes really interesting. Like, oh, were these more animals that were living in these more inland habitats rather than out in the open? I think it's too early to really know that with confidence, but it's pretty exciting. How come we haven't found these dinosaurs yet in Montana? Well, we might, and that's pretty cool. It's something to like look forward to. So, oh, there's a nice little artist reconstruction of this little baby oviraptor curled up inside of its egg. And there's some of that ornamentation on the surface of the egg and then the egg cut. And so you can see through a thin slice the kind of different structures of the calcium and the crystals within the eggshell that let us connect the Idaho eggs over to these eggs in Asia that have a little baby inside of them. Very cool. Okay, so now my job then as the curator in Idaho was to be like everything in my collection that isn't Eryctodromeus almost is eggshell or partial eggs. And then of course I have this set of two eggs. And so we figured, you know what we have to do? We have to take a risk and we have to put out all the bones we have, all the little theropod teeth or whatever, but also figure out a way to show people this amazing giant oviraptor because it's a really big animal. Like I said, these eggs are 15 inches long. And so what we did was here in Pocatello in our museum really early on, and by that I mean like 2010 or so, the museum got into 3D printing and digital like kind of virtualization. So we have this Idaho virtualization lab inside of our museum. And so we do all kinds of interesting stuff. Happy to talk about it if you guys have questions. But for the last like 2 years, me and some of the techs and students in that lab sculpted digitally from scratch. We're looking, of course, at tons and tons and tons of real fossils, and I'm sharing the things we're doing with experts on oviraptors, sculpted bone by bone by bone by bone by bone, a giant oviraptor that would be biologically convincing and the right size. And so what you're seeing in that image there is the back part of the skull and then the first cervical vertebra, so the first neck vertebra of this giant oviraptor. This is a little ridiculous, but it was funny because we're looking at this thing for so long. I got all these ridiculous emails, including things that had titles like this in my professional inbox. Here is the blueprint, and here is the like 3D render of this animal that we built bone by bone. And please, if you're a dinosaur person, talk to me more because I'll tell you all the different people that I was so stressed. I was like emailing this person, like, does the coracoid seem okay? And they're like, yes, that looks great. I'm like, okay, thank you, thank you, thank you. And then we printed this bad boy bone by bone by bone. And we're a little museum at a kind of modest size university. And so you guys probably know the armatures and the structures for mounting big dinosaur skeletons are hugely expensive, almost always six figures. And so how are we going to do this? We're printing it in-house. Okay, we can afford the plastic and we already have 3D printers, but we need to put this in our museum. And so what we ended up doing, there it is getting printed, and us like playing with it and trying to make sure it all works, is we had students in our automotive department who are usually painting cars, paint the bones. And then we had students in our tech school who are becoming welders and getting their certificates, build us an armature. So this thing is not perfect, but it also cost me very little money to build a huge giant Oviraptor skeleton, which is really fun. And so here's us in the welding studios, the welding students. You can imagine university admin was extremely pleased with this to have this like cross-pollination across campus. And so there's me holding up the lower jaws there as this thing was sort of coming together. And so it really was us last year before this exhibit opened, standing there being like, okay, should the shoulder blade go here? Or should it go here? And then we say, oh, here. And then there's a one-way ticket where they just drill right through it with a giant, giant drill and slam some metal through. And so like, okay, that's where it's going to go. But we were able to do that and put this whole big Oviraptor together. And so now, please, if I mean, I know you guys aren't that close, but if you ever find yourself in Pocatello or on your way to Wyoming or coming back from Kansas, stop through because you can see all of these different animals. There's way more than just Eryctodromeus and just this Oviraptor. We have a new ankylosaur that's certainly a new species, and a bunch of really cool crocs. And there's a little tyrannosaur that LJ described a couple years ago. So small thing. If you know Siskiytyrannus or Moros, it's much like that, a little tyrannosaur. But there's this whole really great fauna from Idaho. And so some of you maybe don't think Idaho's Pacific Northwest. My town, Pocatello, our slogan is Gateway to the Northwest. But we're hopefully part of that. And this is this rare upland fauna. Now I want to jump and totally switch gears again to Washington. So Oregon's got the toe. Idaho's got a lot of scraps that you have to work hard to like squint and see the Cretaceous. Washington's just like Oregon, though. I wish I was able to be there in person because I'd ask you guys if any of you know this place because a lot of rock hounds and fossil people do know this place. But this is Susha Island in the San Juans. It is almost the northernmost piece of land out in the Salish Sea that is America. Everything behind this photo in the distance is Canada. It's very, very close to the border. And right over here on this beach is a really wonderful exposure of Cretaceous marine rocks. And here are those exposures. I cannot believe I am part of the Nanaimo group, and I can't believe I'm forgetting the name. I'm quite embarrassed about it. Let's see if it comes back to me. But two of the people who collect, you guys might know Dave Starr, Geddert and Dave Starr, Jim Geddert and Dave Starr. They were out walking this beach because this beach is absolutely covered with Campanian-ish, maybe a little bit older too, Santonian invertebrates. So inoceramid bivalves, lots and lots and lots of ammonites, and a few other hard shelly things. And so they were rock hounding. This is a state park, so they had permits. Everything they collect would go back to the Burke Museum in Seattle. And so when they were walking, they actually found a chunk of dinosaur bone, or sorry, I shouldn't say that. They found a chunk that they thought might be bone, and they actually just left it. And then when they went back another time, that piece had moved. They found it again and then figured out where it went. And when they found where it went, they realized there was more of something going into the hill. And so it was at that time that they took a picture and emailed the curator of paleontology, Chris Cedor, at the Burke Museum. So that was my PhD advisor. And at the time, I was a graduate student. He works in the Permian for the most part. And so he was like, hey, Brandon, come here. What do you think? They just sent this from Susha. And I like got huge eyes because I thought, okay, this is marine rocks from Washington. Washington doesn't have any plesiosaurs or mosasaurs yet. That's what that is. We need to go out there. And so me and a couple other people, I was a couple years into grad school at the time, and a couple people from the Burke, one of our lead preparators, our collections manager, we took a boat with the State Park Service out to Susha Island and went to go find this thing. And it didn't take us more than a second of really actually being there with the fossil. And there it is in all of its not that great glory to realize, oh my gosh, this is definitely not a plesiosaur or a mosasaur. It's not a big reptile bone. It's certainly bone. You can see the spongy cortex texture, but that gray sort of cylinder that you can see sticking up is mud. It's the same mud that makes up the rest of the formation. And so what you're actually seeing there is like a tube, the hollow cavity inside this bone, the medullary cavity of a long bone. And the only animals in the Cretaceous that should have long bones that have an inner cavity that's many inches across are big dinosaurs. And if anything, maybe even big theropod dinosaurs. And so getting this thing out of the ground was wild. We are at like low tide. So we had to work really quickly. This thing is quite usually underwater. One thing that was fun is in the mud, like the fossil mud, the mud rock of the formation, there are little Cretaceous bivalves that lived on this bone. And then because we had it at high tide, there were also like absolutely living barnacles and things attached to this bone. So this bone has been an anchor for a lot of invertebrates for quite a long time. Anyway, we had to use a rock saw. As you can see, this is solid mud, and this thing is basically in the foundation of the island. It's not in a hillside, it's not in the cliffside. And so here's some pictures of us. That's me in the red hat, uh, 12 years ago now, cutting around and cutting around and cutting around this rock. And as you see these pictures, you might be able to tell, I can't remember, that the tide is coming up the whole time. We basically had 5 hours to try, or we'd have to come back next month to get this bone out of the ground. And so here we are chipping all around it using chisels. If any of you guys have excavated dinosaur bones before, or really any big fossils, pedestaling, working your way around a bone, getting it isolated, and then covering that with plaster, and then trying to break that off and have it in a nice plaster jacket. We couldn't wait for that. The tide was coming in, and we actually started to get water coming into the little things we were digging, the little canals around the bone that we were digging. So we ended up using sledgehammers and the rock saw to just smash this thing out. If you ever go to Seattle and see this bone, there's a very pretty painted, but you'll tell, cut right through the middle of the bone where the rock saw went right through it, because our chief preparator, he's the guy in the blue shirt up there, Bruce Crowley, he at the time was like, we got to get it out now. And I was like, no, we can't. It's our only dinosaur. And he's like, that's too bad. And then he just cut it in half and we busted it out of the ground. So if you go to Seattle, you will see there's a never to be repaired section of it missing, but that's okay. It ended up being fine. And so if I show you, it was actually a humongous pain to figure out what this thing was. So the Susha Island dinosaur is the thing on the bottom of that image. The beautiful brown bone in that image is not from Susha. But I went to Bozeman, because Bozeman is a place at the Museum of the Rockies where if you want to figure out what dinosaur bone you got, you can like just look around and see all the dinosaurs they have. So for a long time, I actually thought this was the distal end, the far end of a hadrosaur tibia, so a duck-billed dinosaur tibia. As you might imagine, ecologically, duck-billed dinosaurs are way more abundant than a lot of other kinds of dinosaur. They're the big herbivores. Herbivores tend to be more common. A lot of the dinosaurs that are known from ocean rocks the world over, that includes dinosaurs that have washed out to the sea that is now Kansas or on the West Coast generally, are hadrosaurs, just because. It's also ankylosaurs too, the armored ones. You'd expect plantators to be more common. But then I went up to the Royal Tyrrell Museum in Drumheller in Alberta, Canada. They also have what is, I would say, a ridiculous amount of dinosaurs that you can sort of peek through. And when we were there, I realized like this femur, which is a bone that is belongs to the Tyrannosaur Daspletosaurus, is actually a almost perfect dead ringer of anatomy for the Susha Island bone. And so I don't know if you can see my mouse or not, but this right here would have been the cartilage cap that's missing. Here is the cartilage cap on a Daspletosaurus bone that's still there. It ossifies, it does become bone, but it's a separate ossification. And so it's missing from the Susha bone. And then there's on the underside is that tube, so that long shaft of the bone. And then this ridge right here on the top really is what sealed the deal. That's the fourth trochanter, which is the major muscle insertion point on a lot of dinosaur bones. And so a horned dinosaur, duck-billed dinosaur, and a tyrannosaur, they're all going to have that structure, but the shape and the positioning of that structure is extremely dependent on what dinosaur it is of those big groups. And so we were actually like staring in the face of like, oh my God, is Washington's only dinosaur like a late Cretaceous large theropod? And so there's the paper. You're welcome to go read it. It's in +1, so it's open access. We can't actually say in the paper that it's a tyrannosaur. There's not enough anatomy here. There's not enough information for us to say that. But we do kind of like painstakingly go through all the large theropods it could be and are like, come on. On this continent at that time, it almost certainly has to be a tyrannosaur, which is so beyond amazing. The other thing we did in that paper was summarize this kind of problem I've been talking to you about. I've been focused on the Pacific Northwest. This was a little bit different. This was talking about the West Coast generally, or the Pacific Coast of North America generally. Those are all of the places from Alaska to Baja that you actually get Mesozoic dinosaur fossils on the West Coast. And you can see it's really, really scrappy. Basically, there's a couple of formations in Baja, California, in what's now Mexico, that are pretty rich, and everything else is bits and pieces. A little armored dinosaur here, a little duck-billed dinosaur there. I just told you guys, I'm sorry. I published this in 2015, and that was when we thought that Oregon Sebastian Sandstone thing was a hadrosaur, and it's probably not. But don't worry, because Greg Italic saved you, and now there's a toe from Mitchell. So Oregon still has a dinosaur, and it still would have this silhouette, but it's not whatever it says there under number 4. Oh, there it is. Washington's number 3 with that big glorious tyrannosaur, and it's the Cedar District. I'm so sorry for forgetting formation within the Nanaimo group. And so that was really cool. You can imagine everybody in my museum, the Burke at the time, was beside themselves. It took a long time to prep the bone, and eventually, when the PR people heard that we were like just kind of working on Washington's only dinosaur, they all lost their minds and became kind of a big thing. So we did a big press release when it came out. So there's me with much shorter hair 12 years ago. And that's Chris Cedor, who's curator at the Burke, co-worker formerly of Liz Nesbitt, who just spoke with you guys, I think, last month. And there they are, the Daspletosaurus from Canada, and then our bone that's very similar from Washington. If you found this bone in Montana, you would not pick it up. You wouldn't look at it. But because it's from Washington, it is celebrated and well known. You guys might know that this has actually been called, not through my efforts or at all. Washington has a state dinosaur, just like Idaho does, and it got named Sushasaurus rex, which I really do not condone, but I can't help it. And a bunch of fourth graders made it happen, and Jay Inslee signed that bill a couple years ago now. And so when it first came out, people like Ray Troll were so excited, of course, because he's working all up and down from Alaska. And so that was his drawing of Sushasaurus washing out to sea, falling to the bottom. All of those ammonites and baculites are real. They are the same animals you find at the same island. And then there's this sticker I just stole from Twitter. This artist, Emma, she posted it like 3 days ago, and I'm gonna buy that sticker when it comes out with that star up there on Susha Island. And so you guys might know this book. There's Cruising the Fossil Freeway. There's also Cruising the Fossil Coastline. This book came out in like the later 2010s. And Kirk Johnson, who's the director of the Smithsonian, and Ray Troll, who illustrated these books, they're, big Washington people. And so that Suchosaurus is actually on the book on the back cover. There's a Tyrannosaur, which doesn't seem right for a West Coast book, but that is supposed to be the Suchosaurus, which is pretty fun. And so as Oregon people, I bet you have this book, but if you don't, you could get it. And anyway, I guess I was looking forward to talking to you guys as an Oregon group because, every place in the world has fossils. Every place in the world gives you some level of insight into the past. And you really have to stitch together all these different places to get a more complete picture. So if you want to know about Pacific Northwest dinosaurs, the only things you get are a little hadrosaur chunk from Oregon, okay fauna, but it's pretty scrappy from Idaho, and another gross chunk from Washington. End of story for the Pacific Northwest. But that's, I guess, until you guys find some more stuff, and I'll look too. And that's all I got for you.
That's fantastic. Yeah, thoroughly enjoyed by the group here.
Oh, good.
Yeah. No, this is really fun. And a side note, thank you, Greg, for the volume, because it was great to hear our speaker nice and loud for the first time. Greg's going to give you some insight on dinosaur in Oregon, because we know a tiny bit more.
Hi,
Oh, yeah.
I'm Greg Carr.
Oh my God, cool.
And we had a dig a few years ago out there at the Mitchell site where
Okay.
Dr. Italic found his toe bone. After we heard about the toe bone,
Yes.
my daughter and I have been to that site quite a few times digging for ammonites. It's been dug for ammonites for 60 years.
Okay.
And
So there's really not a lot of other toe bones.
and we
probably.
realized that, if there's going to be bone there, then it's going to be in the scrap piles that
Mm.
that litter that area, because people go through it digging through the shale to get ammonites. When they find a hard nodule, they just throw it on a scrap pile. And so we went there and searched through the scrap piles and found several more dinosaur bones.
Mm.
And then we had an official dig permitted by BLM, the Dr. Italic permitted, and had to dig there and found another entire bone and about 15 fragments of bone, all consistent with being coming from the foot of that animal.
Oh, how
And
wonderful.
those bones are now all down at the University of Oregon. Dr. Italic has retired, so I don't know if anybody's going to write it I would imagine though, you could get a hold of Ed Davis and he would loan them to you.
Yeah, interesting, interesting. Greg and I had the other Greg Vitalik and I had lunch at the Society of Vertebrate Paleontology in gosh, I want to say Calgary maybe, or maybe it was Dallas. So 16 or 17, 2016 or 17. And we talked about some scraps he had from the coast that if he wondered if it was like cortical bone, but it was really beat up. I didn't hear anything about more from Mitchell. I did review this paper, this Mitchell paper when it came out, and I really like wrote like, are there other pieces? And that's so wonderful to hear that there is. So I should get in contact with them because um, it's the same kind of thing. If you found these bones in Utah or Wyoming, you probably wouldn't think too much of them, but they're really important given their provenance. So that's wonderful to hear.
Yeah, and most of the bones, to be honest, were found by my daughter, Gloria.
Oh, good for her.
All right, other questions? Anybody here? Anybody online have questions? There's a 3 chat comments I can look.
Oh, let me open the chat. I don't have to have my
Haven't
screen
looked.
going either.
Let's see what that is. It might be with volume or
Oh,
something.
that's from the share. That's about your awesome mammoth.
Oh, okay, cool. So do you have insights on that mammoth tooth? You just gave a thumbs up and nodded.
Oh, when you said Alaska, I mean, it looks consistent. And
Just the coloring of it?
yeah. But I mean, I have no idea, honestly, how variable
Okay.
that is. I
Okay.
accidentally became the curator of a Pleistocene collection, so I'm learning as I go. But looks like other Alaska stuff I've seen.
Cool. Let's see, how many do we have on? My mouse is not operating here. We ended up with quite a few people online here.
Yeah, that's a lot.
So chat.
I got a question that
Yes, sir.
the bone that you think is turtle, who looked at that
Yeah.
and what did they have to compare it to that really looks compelling?
Let me do my homework real quick live. I don't remember because when I wrote the paper in 2015 on the Susha bone, the Cape Sebastian hadrosaur, it had been mentioned in a book about California paleo. It was a book about California dinosaurs that came out probably 50, maybe almost 20 years ago now. And it mentioned, oh yeah, and right across the border on these beaches at the Cape Sebastian sandstone, there's a hadrosaur. And then I only ever heard people talk about it, and I cannot remember who was like, it's in private collections, which is I don't want to be too curmudgeon about it, but when it's in private collections, like you can't publish about it in certain journals, and some scientists won't see it. And there was one person, I can't remember who it was, who did see it in its private collection and said it is like, a long piece with pieces that come off, but I don't remember if they said it could easily be a dramatic helid, like some kind of sea turtle shell, or if they said it definitely was. But then it was in private collection, so I actually haven't heard anything about it in a long time. It's in the paper. I say something about that. I just haven't checked.
I think it's David Taylor.
Yeah, Dave Taylor was the one who excavated that from down
Is
there.
Dave Taylor here? That's what I love about giving talks like this. Is I put my foot in my mouth, and then all 3 of you stand up and say it's actually us. So
Yeah, Dave Taylor's not in attendance, and he has.
Oh, okay. I would have loved to know more, or just seen photos. I've never even seen
I
photos.
thought it was published. I may have some information on it and I'll get it to you.
Please do, because that would be an oversight on my part somehow. I knew about the Mitchell one, like I said, because I reviewed it. But these papers are pretty niche, so that would be. I would love to know. It certainly would be completely normal and believable for there to be a hadrosaur sacrum from the Cretaceous of the Cape Sebastians. I mean, sounds great. Sounds completely good to me.
Okay, yeah, we got another question here in the audience. Where was it's in +1s. He was asking where the paper was published, so it's
Yeah,
+1. It's online.
+1. I can I won't click you through all of it. I'll just go right to it. Oh, sorry if that was too disorienting.
No, we track things like that. I do that all the time.
Yeah.
Email that me and I'll send
Yeah.
it.
So there's like the full citation if you really want it.
So yeah, if you have a link to it, if you send that to Tara, then we can send it out to our
Sure.
listserv.
Sure.
everybody access it that way. I definitely want a copy of it. That's cool.
Yeah. Yeah.
Cool. Other questions? We ended up 11 here in person and 19 plus you online. So you have 30,
Oh, great.
30 in attendance for your talk. And I don't know if there's double people, but at least there's 20 guests, including you. Fantastic. Any last questions? I don't see any here, but anybody online? All right. Well, thank you so much.
My pleasure. And hey, you guys are the eyes and ears out there looking for other stuff. You know, you'll find it.
So I presume that you're open to emails if people have further questions.
Sure,
you
sure.
think
Yeah,
of?
of course.
Okay.
Of course.
We'll send out the email address along with the link for the article. And once people read it, because I know a lot of our members will, then they may
Sure.
have questions and some
Yeah,
insights.
that sounds great.
Great. Thank you so much for your time. Really appreciate
Yeah,
it.
nice to meet you guys. Nice to see you.